So today we are going to talk about production with two variables, and the graph or the curve that we show or plot in the form of a graph is known as isoquant. And isoquants are basically curves that show all possible combinations of inputs that yield the same output. So if we divide the input into two categories, say for example, labor and capital. So all those combinations of labor and capital that produce same level of output is known as isoquant. So in this table, you may see that the figure of 75 has been encircled here and here and then here. So in the first column, 75 units of output can be produced either by using 1 unit of labor and 5 units of capital. The same 75 units of output can be produced using 2 units of labor and 3 units of capital. And in the third column, 3 labor and 2 capital, 2 unit of capital can produce the same level of output, that is 75. And in the fifth, in the last one, 5 units of labor and 1 unit of capital can produce 75 units of output. So if we plot these combinations, on x-axis we have labor and on y-axis we have capital. And if we plot, so the curve looks like a downward sloping curve. So this curve basically shows all those combinations of capital and labor that can produce 75 units of output. Isoquant map graph. Isoquant map is a graph that combines a number of isoquants. So if we show a number of isoquants in the same graph, that can be called as isoquant map. So isoquant map is used to describe a production function. So isoquants are basically used to describe a production function. So here in this graph, we have plotted 3 isoquants. The first isoquant is for the output of 55 units, then 75 units, and then 90 units. So the more number of units of output is there, the right side, the curve will shift. And if we reduce the number of output, the curve will shift left side. So these are some of the properties of isoquant. They are convex from below. As you can see that these are convex. These are not a straight line, but these are curves and convex from below. The higher the isoquant, the higher the output. So the higher the isoquant, the higher the output. So the more right and upward a curve is, it basically denotes the more level of output. Then they do not intersect with each other, and one isoquant does not intersect with other isoquant. So one curve does not intersect with other curve. So these are some of the properties or features of isoquants. And the reason why these curves are not sloping and not a straight line is because of marginal rate of technical substitution. Marginal rate of technical substitution is the amount by which the quantity of one input can be reduced when one extra unit of another input is used, so that output remains constant. So in reality, what happens, say for example, labor and capital. There is a production function in which there are only two inputs, labor and capital. So labor cannot be 100% substituted by capital. Similarly, capital cannot be 100% substituted by labor. So there comes a stage where X cannot be substituted by Y in a complete manner. So the rate at which one input can be substituted or replaced by another input is called marginal rate of technical substitution. So if two inputs can be substituted against each other, in that case, this line will look like a straight line. But that is not the case, because the marginal rate of technical substitution is not 100%. So what is this marginal rate of technical substitution? The amount by which the quantity of one input can be reduced when one extra unit of output when one extra unit of another input is used, so that output remains constant. So in the form of formula, we can write like this: MRTS is equal to change in capital input, change in labor input. So sigma delta K divided by delta L. Delta is basically change. Change is denoted by delta. So delta K divided by delta L. So if this is 1, if delta K divided by delta L is 1 or 100% technical substitution, which means capital can be replaced by labor 100%. So, and without impacting the output. Similarly, labor can be replaced by capital without impacting the total output. But this is not the case. Normally, this is not the case. One thing cannot be substituted by another thing in a 100% manner. Some portion is still needed. Some amount of labor will still be required. Even if we employ a lot of machines, some labors will be, still required. So those labors cannot be, 100% replaced by machinery or capital. So that is why these curves look like a curve instead of straight line. And if the marginal rate of technical substitution is 1, in that case, isoquants will look like straight line, like this. A, B, C. This is these are the straight line. So in this exceptional cases, or in this special case, labor can be replaced 100% by the capital, or vice versa is also true, that capital can be replaced by labor and labor can be replaced by capital. But this is a special case which does not happen normally. Then another special case with isoquants is that sometimes a fixed proportion is required. Say for example, one machine, one person, one machine, one labor, two machine, two labor, three machine, three labor. And this proportion, I mean, for example, the proportion is 1:1. So then sometimes the nature of the production is such that the proportion has to be maintained. So if the proportion is 1:1 between capital and labor, it has to be, it has to remain constant, irrespective of the level of production or level of output that we are using. So in that case, the isoquant will look like L-shaped. In that case, the isoquants will look like an L-shaped. L-shaped because one type of input cannot be replaced by another type of input, cannot be substituted by another type of input. So production function with L-shaped isoquant, so that only one combination of labor and capital can be used to produce each level of output. The fixed proportion production function describes situations in which methods of productions are limited. So in this kind of method of production is less flexible, where choices are not available uh, between different kinds of inputs. In that case, this isoquant will look like L-shaped, because we have to maintain certain fixed proportion between different types of inputs. In this case, the two types of inputs we have taken, capital and labor. And at each level of production, say for example, Q1, Q2, Q3, these are three levels of production. Levels of production. Maybe at Q1 we are producing 100 units, then here we are producing 1000 units, then here we are producing, Q3 is 10,000 units. At every level of production, the proportion between capital and labor has to be fixed. Whatever is the production, it may be 1:1, 2:1, or 1:2, 1:3, or whatever. So now coming to the long-term production function. In cost, initially we started with short-run production function, in which we talked about diminishing returns to scale. Now coming to the long-run production function. And as we know that long-run production function, long run is a period in which all inputs are variable. So in this, we will try to understand the behavior of input and output in the long run. So return to scales, rate at which output increases at inputs are increased proportionately. So in the long run, since every input can be increased, so we can increase proportionately. But in the short run, we were keeping certain inputs as constant, and then we were increasing other inputs. But in the long run, we increase all inputs. So a situation in which output more than doubles when all inputs are doubled, that situation is called increasing returns to scale. So if we double the input and our output is increasing by more than double, this situation is called increasing returns to scale. Increasing returns to scale. And if we double our input and our output is also doubled, so the change in input and output is equal, that situation is called, that phenomena or that situation is called constant returns to scale. And a third situation in which we are increasing the input by 2x, and the output is the increase in the output is less than 2 times. This situation is called decreasing returns to scale. So in the long run, these are the three possible scenarios. Either the production function or the firm is facing increasing returns to scale, or the firm or the company or the factory or is facing a constant returns to scale. Or a third situation is the firm may also be experiencing sometimes decreasing returns to scale. So in the long run, these are the three possible scenarios for a firm which is into the business of producing something. Either it may be experiencing increasing returns to scale, or constant returns to scale, or decreasing returns to scale. Depending on several factors, we will talk about those factors. Graphically, this can be shown like this. These are isoquants. This 10, 20, 30, these are the level of production. And these three isoquants are equidistant. the distance between first isoquant and this isoquant is equal. Similarly, the distance between this isoquant, the middle one, and the upper one is equal. So this is the situation in which the firm is experiencing constant returns to scale. Constant returns to scale because we are doubling the input and the output is also the increase in the output is also same as the change in the input. So when a firm's production process exhibits constant returns to scale as shown by a movement along line OA or 0A in part A, the isoquants are equally spaced as output increases proportionally. So if the change or the rate of change in input and output is same, if the rate of change that is delta input divided by delta output is same, in that case isoquants will be equidistant. The distance between this and these distance will be same. So this is an example of constant returns to scale. Constant returns to scale. And if the firm is experiencing increasing returns to scale, in that case, isoquants, the subsequent isoquants will come closer to each other. So the distance between 10, the level of when the level of production was 10, and when the level of production became 20, then from 20 to 30, the distance has decreased. So the isoquants have come closer to each other. So this is what happens if the firm is experiencing increasing returns to scale. Increasing returns to scale means if the output is becoming more than double, if we are increasing the input by 2 times. So if you are doubling input and the output is, the increase in the output is more than double, in that case the firm is experiencing increasing returns to scale, and the isoquants will look like this graph that is on the right side. However, when there are increasing returns to scale as shown in B, the isoquants move closer together as inputs are increased along the line. So returns to scale show the output effect of increasing all inputs. All inputs, because in the long run, all inputs are variable. All inputs are variable. There is no concept of fixed input in the long run. So output elasticity and returns to scale. So this increasing returns to scale, decreasing returns to scale, and constant returns to scale, the same phenomena can be defined in terms of elasticity also. Elasticity that you have studied in the first unit, which is nothing but the degree of change or the degree of change in the output in response to the change in the input. So this concept is called elasticity. So elasticity of quantity, the change in output divided by change in all input. So output elasticity is change in Q divided by change in X, where X is all input, maybe labor, capital, etc. So if the elasticity of the output is more than 1, in that case, the firm is experiencing increasing returns to scale. And if the elasticity of output is equal to 1, that situation is the situation of constant returns. And if the elasticity of output is less than 1, that situation is the situation of decreasing returns to scale. So graphically or formula wise or this can be calculated as elasticity of output. So if we have figure for output and if we have some figure for input, to what extent input has been increased, and as a result how much output has increased. So if we have these two figures, we can calculate elasticity, and if the elasticity is more than one, we can call that the firm is experiencing increasing returns to scale. And if the change in input and output is equal, that in that case we can say that the firm is experiencing a constant returns to scale. And in the third situation, if the change in output is less than the change in the input, that situation is the situation of decreasing returns to scale. Graphically, this relationship can be plotted like this. On x-axis we have unit of input, and on y-axis we have the unit of output. If the firm is experiencing a constant returns to scale, in that case it will be a straight line. And if the firm is experiencing increasing returns to scale, then in that case it will be a curve, upward sloping curve, or the increase in the output is exponential like this. It's not a straight line, it's a exponential growth. And in this case, decreasing returns to scale, it is also a curve, but downward, but the speed of increase is reducing over time. So these are the three possible scenarios or three possible situations that a firm can face in the long run. So in the long run, all costs are variable. There are no fixed costs in the long run. In other words, in the long run, total cost equals variable cost. Because there is no need to differentiate between fixed and variable in the long run. And average total cost equals average variable cost. So whether we call it average total cost or average variable cost, it is same thing if we are talking about long run. So long run average cost curve, a curve that shows the lowest cost at which a firm is able to produce a given quantity of output in the long run, when no inputs are fixed. The concept of economies and diseconomies of scale is also related to the long run production function. Economies of scale is a situation when a firm's long run average cost falls as it increases the quantity of output it produces. So if a firm decides to increase the level of production, and because of increasing the level of production, the unit cost or the per unit cost is decreasing, that situation is called economies of scale. So say for example, there are two factories. One is producing 1000 logs per day. Another factory is producing 10,000 logs per day. So if the unit that is producing 10,000 units of log per day has lower cost per log, in that case we can say that that firm is experiencing economies of scale, because of larger scale of production, the unit cost has reduced. The opposite, sometimes the opposite is also true. Sometimes instead of economies of scale, the firm faces diseconomies of scale. And diseconomies of scale means if the level of production is increased, the average cost per unit starts rising. So if the average cost per unit starts rising because of increase in the level of production, scale of production or level of production, that situation is called diseconomies of scale. So in the long run, there are two situations. If the firm is experiencing economies of scale, it will face increasing returns to scale. If the firm is facing diseconomies of scale, in that case it may experience decreasing returns to scale. And if the forces of economies and diseconomies are equal, in that case it will be called constant returns to scale. So the curves will look like this. This is long run marginal cost curve, and marginal cost curve cuts average cost curve from below, and this is the point where average cost curve reaches its minimum. So marginal cost curve cuts average cost curve at its lowest point. So let me just check whether you understood the concept of economies of scale or not. On your screen, there is an example. There is a firm. You should keep in mind that we are not talking about two firms. We are just talking about production. So it may be a single firm. A single firm has to decide between scale A and scale B. So in scale A, the 100 units of output can be produced, and in scale B, 300 units of output can be produced. And the number of input required for producing 100 units of output and 300 units of output has been given here. That instead of capital has doubled, land has also doubled, and labor has also doubled from 4 to 8. And as far as the output is concerned, so it has tripled. It has increased by 3 times. The increase in the output is 3x. So just to check your presence of mind, tell me whether this situation is a situation of increasing returns to scale, constant returns to scale, or decreasing returns to scale.
So increasing returns to scale.
Increasing.
Okay, thank you very much. So because input has been doubled, but the output, the change in the output is more than double. So we can say that it is a situation of increasing returns to scale. Now you can do some more calculations. Assume each unit of capital costs ₹5, and the cost of 1 unit of land is 8, and the cost of 1 unit of labor is 2. Calculate total cost, that is this column, that is total cost. Then calculate average cost. Average cost is nothing but total cost divided by number of output. Average cost for the 2 different scales, sizes of production facility. What happens and why? So you have to calculate this total cost. First calculate this total cost, then calculate this average cost. These are units, and the price of per unit has been given here, ₹5, ₹8, ₹2. So 5 multiplied by 5 plus 3 multiplied by 8 plus 4 multiplied by 2. Similarly, you can do for scale B also. So total cost will be can be calculated. After calculating total cost, just divide that total cost by number of output. That is 100 in this case. So the total cost is coming out to be 570. Is it correct? $380. And if we divide,
cost will
yes,
be 50.
So it will be 57.
57 it will be.
okay, it
Yes,
will be
sir.
50.
Yes, sir.
So 57 divided by 100, so that will give us average cost. Average
0.57.
0.57. Now do this for the scale B also.
So total
114.
cost
1114.
114.
114, sir.
Okay, 114. 114 divided by 300. How much?
0.38.
Okay. So what is your observation out of this? Average cost per unit has reduced or has increased?
Sir, reduced.
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 So the firm is experiencing economies of scale, because this is what the definition of economies of scale is, that if we increase the level of production, scale of production, the unit cost decreases. The unit cost initially was 0.57, but when we increase the level of production, the unit cost or per unit cost has reduced. It has become 0.38. Don't get confused by looking at the total cost. Total cost will always increase. Total cost at scale A was 57. At scale B, the total cost has become 114. So it will, or it is supposed to increase at every level of production. We have to look at the average cost per unit. So at scale B, the average cost per unit has reduced. So we can say that the firm is experiencing economies of scale. So if the firm decides to produce for scale B, at scale B, in that case, the average cost will be lower. So doubling the scale of production, a rise of 100% has led to an increase in output of 200%. Therefore, cost of production per unit has fallen. Do not get confused between total cost and average cost. Overall cost will rise, but unit cost can fall. And unit cost can fall because of economies of scale. Because of economies of scale. So economies and diseconomies of scale, situation in which output can be doubled for less than a double of cost, that situation is called economies of scale. And a situation in which a doubling of output requires more than a doubling of cost, that situation is called diseconomies of scale. And economies and diseconomies of scale can be defined in terms of elasticity also. So economies of scale are also measured in terms of cost output elasticity. Cost output elasticity is the percentage change in the cost of production resulting from a 1% increase in output. So if the elasticity of cost is less than 1, that situation is economies of scale. If the cost elasticity is more than 1, that situation is diseconomies of scale. And the third situation is elasticity of cost is equal to 1, a situation in which a firm is neither experiencing economies nor diseconomies of scale. Now coming to, initially we started talking about diminishing returns to scale. Now we are using the term economies and diseconomies of scale. Both are different things. What is the main difference between these two things? Diminishing returns to scale, a firm faces this situation in short run period. And as far as the economies and diseconomies of scale are concerned, these are long-term phenomena. A firm faces economies of scale or diseconomies of scale in the long run. So if we are talking about short run, we have to use the word diminishing returns to diminishing returns, the law of diminishing returns. And if we are talking about long run situation, long run period, in that case, the accurate term is economies of scale and diseconomies of scale. So the concept of diminishing returns and diseconomies of scale may seem similar, but in fact they are unrelated. Diminishing returns applies only to the short run when at least one of the firm's input, such as the quantity of machinery is used, is fixed. The law of diminishing returns tells us that in the short run, hiring more workers will at some point result in less additional output. Diminishing returns explains why marginal cost curves eventually slope upward. These economies of scale apply only in the long run, when the firm is free to vary all its inputs, can adopt new technology, and can vary the amount of machinery it uses and the size of its facility. These economies of scale explain why long-run average cost curves eventually slope upward. So in the next class tomorrow, we will talk about why, what are the reasons, what are the causes of economies of scale, and then we will talk about what are the causes of diseconomies of scale. So for today, let us call it a day. Thank you very much for.
Thank you, sir.
Thank you, sir.
Thank you
Thank
very
you, sir.
much.